Hey guys, my name is Suyash and welcome to my YouTube channel. In this video, we are going to deep dive into events in Google ADK, and by the end of this video, you will have a complete understanding of what events mean, what are all the possible attributes of the events, and how you can extract important information from events when building AI applications. Let's get started. So in this tutorial, we are going to look at what events are as part of Google ADK. Now, an event is the runtime's basic unit of communication. Now, in the previous video, in the previous tutorial, we looked at what an ADK runtime is, which is essentially an event loop where multiple events are emitted by the agent as part of a single invocation. Okay, so do check out the video. The previous video is a prerequisite for this video. So an event is a basic unit of communication. It is a record that represents something that happened during the agent's run. Now it could be the user input, it could be agent output, it could be tool related outputs, it could be state updates, it could be control signals, or it could be errors. And it's built on top of the LLM response structure. Okay. Now, why events matter? They give us complete chronological history of the entire run, which allows us to debug and understand the behavior. They carry the state and artifact changes. They enable the control flow, meaning if there is a transfer or handoff to a different agent, if there's an escalation or even end of the run. They power the session history. So in the previous tutorial, we looked at different components of this event loop, and session was one of the component. Now the session is the record of the entire conversation, right? And each turn of that conversation is an invocation, and each invocation has multiple events. So these events ultimately power that session. Okay. Now an important note is that as part of this code, I have included the complete schema of the event class. So this is from the documentation, but I've added one-line explanations to each of the attribute. So you will find the complete exhaustive set of attributes which you can use later. But what I want you to note is that the attributes here or the keys here have camel case, right? As you can see. But in Python, if you want to extract the attributes, you need to use the snake case. For example, invocation ID here is in this way, but in Python, you will have to use invocation underscore ID. Okay, do remember that. Now let's try to understand conceptually what an event is. And at a high level, the event is a combination of metadata, content, actions, and runtime details. Metadata is who created the event and when or where did it happen, right? So you have author, you have ID, ID of the event, the timestamp, the invocation ID. So we saw in the previous video that an invocation can have multiple events, right? So the events are grouped under this invocation ID. Next is content. Content is the actual payload of the event, right? Which tells us what was said or what was exchanged. Content.parts is the primary place to look. So remember, parts is a list. So whenever we want to extract information from that, we need to iterate through it. Now parts may contain text or a function call or a function response or many other attributes like code execution and so on. Okay. Then we have actions. Actions are the side effects or control signals the runtime should apply next. Okay. For example, actions could be a state change. It could be an artifact update, right? Change in the file. It could be control flow signals if there's a transfer to the agent and so on. Now from here onwards, to make things more clear, we will run agents created in the previous tutorials. Okay. And we'll compare the ADK web UI payload with what we have mentioned here. Okay. So let's pick the finance assistant agent which we created as part of the function tools tutorial. It was second tutorial which was related to function tools. Now how to identify which type of event this is. Okay. First step, check the author. Now let me send hi to our agent and let's see the events here and let's try to connect. Okay. So first we need to check the author. So here if we observe, the author is the finance assistant. It is the name of our agent. So we got the author, it's the agent name. Next, check the payload. Okay. The payload is found in content.parts, and remember parts is a list. Now in this case, the contents.part is a text. So it is a text message. Now let's understand what will happen if there is a function call. Okay. So as part of this agent, we have a few tools. So I asked it to run a tool. Now let's see how the content changes. Okay. This is that event where there was a function call. So now if you look at the content.parts, you will see a function call, right? So this is a tool call request. So in the case of tool call, you will see content.parts.function call. So we see that here, right? Similarly for tool result, if I look at the next event, in case of tool result, we will see a function response inside the content.parts. Okay. Similarly, there could be just purely state update where content is equal to null and either state or artifact data is available. And if none of these match, then it's probably a control signal where the control is being transferred to another agent. Now, next, let's try to understand how to extract key information from the events. First, the text. We just saw that if you want to extract text, we need to first ensure that the content exists. So here, yes, the content exists. Then ensure that parts exist and it's non-empty. So we do see that parts is there and it's non-empty. Now iterate parts because it is a list and then collect all the dot text across those parts. Next, how to extract the function call details. So we did make a function call here, right? This was a function call. Now, as part of the function call, you will see that there is a function name, which is calculate compound interest. Then there are function arguments. These are provided by the LLM as part of the tool call or function call. Then there are some extra attributes and there is also function ID. Okay. We'll see why this is important in a moment. In the application code, if we want to extract the function call details, we can use this helper method get underscore function underscore calls, which will list all the tool calls if they're available. Okay. Similarly, for function response, it has similar attributes. There is function name, right? There is function ID, there is response. Now the response is a object, JSON object, but when we wrote the code, we ensured best practices, and that's why you see this key value pairs, but ideally you will only see a response object here. Okay. These are custom key value pairs that we define as part of the code. Now an important part, we see the function response ID here, right? Imagine there are multiple function calls in parallel. How do we identify which function call is tied to which function response, right? And that is where this ID comes into picture. If we look at the function call, this ID, right? This ID 8751 is the same ID of this function response 8751. So in order to correlate between the function call and the function response, we can use this ID. There are common identifiers which we will use constantly. First is the ID. ID is the identification of that specific event, okay, here, and it will be unique for each event. And then we have invocation ID, okay, which is here. Now remember, again, referring to the previous tutorial, we said that each invocation has multiple events, which means that across these events, we should find the same invocation ID. So for this invocation of this single turn, you will see that the ID is FD43. Let's look at the previous event. You will see that for the previous event, the invocation ID is also same FD43. Now, because this event was part of the previous turn, that's why you see that the invocation ID was different. Now let's see how to detect actions. Okay. The action object signals change that occurred or should occur. Now always check that it exists before reading it. Now state changes. An action could have state change. Now to demonstrate that, let me choose another agent. So I will choose the content moderator agent as part of the 7th tutorial, which is about callbacks. And inside the callbacks, we have done state updates. Okay. Now, when I send a message, we have a callback which runs. And as part of the callback, first observation is that the content is null. It is not available, which means the type of this event is purely a state update event. Second, you will see that we have the request count key inside the state dictionary and we incremented it by 1. So the action in this case is state update, right, which is the request count. Then there could be artifact changes. So if we upload a file, we update the file, you should see that artifact delta action. Then there is control flow signals. To demonstrate this, let me choose our essay refiner agent. This essay refiner agent is from the 6th tutorial, which is about the loop agent. As part of this loop agent, we have defined a tool, and inside the tool, we set the escalate action equal to true. Okay, let me demonstrate that now. As part of this agent, we have an initial writer which will write the essay. Then we have a critics agent which will criticize the essay and provide some suggestions. Then there is a refiner agent which would refine based on those suggestions. And this to and fro keeps happening until the critic agent approves the draft. Now you will see that when the approval is sent, the tool is called. And when I look at that tool event, you will see that there is a escalate action. Okay, now let's see that. So here you see that the critic agent approved the essay and the tool was called. Now if I show you the event, you will see that escalate equal to true as part of actions. This is one of the control flow signals. You will see here actions.escalate, which escalates or terminates the loop. Okay. So this is the demonstration where here you see that the loop was terminated because escalate was set to true. Similarly, in a multi-agent system, you will see transfer agent action, and then there are multiple other actions. So if you look at the event schema here, and if you look at the actions, you will see all the possible actions that may appear depending on the scenario. Finally, how do we determine events which are suitable to show to the user? For that, we determine if it's a final response. So we can use this helper method is underscore final underscore response. This filters out the intermediate steps, right? Like tool call, partial streaming chunks, and internal updates, which are supposed to be used within the application code for logging or monitoring, but you would want to show the final response to the user, right? And for that, you can use this helper method. So that's all for this video. Do check out event underscore schema.json. You can always have this handy because this has the comprehensive information of what this event class contains, what are the attributes and what they mean. And especially if you are an AI developer who develops applications, you would need to know the schema so that you know what information can be extracted and used. That's all for today. If you liked the video, if you found the video helpful, do like, do subscribe, do comment on what else you would like to see, and stay tuned for future videos. Thank you.